Welcome you all to Experimentation Insight. In this video, we are going to see about how does this frequency will connect with vibration phenomenon. Frequency and vibration are fundamentally connected. Vibration is dynamic parameter, which is described as back and forth motion of an object, and frequency is the measurement of how many times that motion repeats per second. A vibrating object completes cycles of movement, and the frequency quantifies the rate of these cycles per unit of time, typically measured in the unit of hertz. Therefore, a higher frequency means the vibration is faster, while a lower frequency indicates a slower vibration. The classic example motion of a child on swing or a pendulum in a clock is a perfect example of a vibration. When we consider cycles per seconds or the number of times a repetitive motion is generated by a vibrating object, usually in 1 second's time period, the frequency is number of cycles per second. We use the unit of frequency is hertz. You can see in the time domain amplitude variations per seconds. In the first case, you can see that 3 cycles in 1 second, which you see in the frequency domain as 3 hertz, the frequency domain on other word FFT or Fast Fourier Transformation, which will convert the time data into the frequency data. In the second example is 7 cycles per second, which is 7 hertz. The real-world vibration data is more complex than what we have seen in the previous examples. To solve this complexity, the Fast Fourier Transform, FFT, will help us to extract the frequency information from the complex time data. In vibration analysis, the Fast Fourier Transform, FFT, is a critical algorithm that converts a time domain vibration signal into its individual frequency components, a frequency spectrum. This spectral analysis helps engineers to monitor machine health, detect problems like unbalance or misalignment, identify natural frequencies for structural design, and predict potential failures. In order to convert the time domain to the frequency domain, we need follow certain steps. In that, windowing is one of the important functions. Based on the type of signal we have to select the windowing option. For vibration measurement, the Hanning window is a standard choice for continuous machine vibrations, offering good spectral leakage reduction without significantly degrading frequency resolution. The rectangular window is best for capturing transient events like impacts that start and end at 0. For calibration and precise amplitude measurement, the flat top window is recommended. We need to define the bandwidth frequency of the FFT based on the interested measurement frequency range, and define the resolution of the FFT, which is nothing but the delta frequency. If it's 0.25 Hz, then every 0.25 Hz will be on increment. For example, 120 Hz after 120.25 Hz, and the number of lines will be automatically assigned based on the resolution and bandwidth selected in the FFT. We hope you enjoy and learning from this video. Thanks for watching, and please do subscribe and support for more informative videos.